We're going to visit Phoenicia during the Ice Age on our walk this morning, and then we're going to go farther back in time. When I do this, in my mind's eye, traveling into the past. We geologists are very good at doing that. We're going to look at bedrock across the street, and we're going to examine that bedrock. We're going to look for the evidence, and we're going to try to understand what it was like on August 17th, 384,917,624 BC. Right here, there was a day. August 17th of that year was just like any other day. The sun rose in the east, it circled over us, above us, it set in the west, and that day came to an end, just as this day will come to an end. In 384 million years from now, when this spot will still exist, our time will seem as giggly distant as that time seems to us. Maybe there'll be intelligent creatures on the planet Earth right here at that time. Yeah. Maybe there'll be some sort of record of the past for them to go and visit. But we're going to have to settle for our day and a visit to our past here in Phoenicia. Well, Tanya, let's take them for a walk. Let me introduce myself a little bit more. I'm still Bob Titus. I became a geologist 60 years ago. 2 moments. I was 6 years old. We moved into a new house. The lawn wasn't in, and I saw a rock, and I bent over and picked it up, and on its surface were fossils, shellfish. And I vividly remember this moment. It was an extremely important moment in my life, one of the most important. And I looked at it, I said, seashells. I didn't know what they were. And I had my mother explain it to me, and she explained to me what a fossil was. A shell which was buried in sediment, which became petrified, and was then called a fossil. And I was truly awed by this. It really affected me. Soon I was wandering around collecting fossils. This is in northern New Jersey. The glaciers had obligingly brought fossils from New York State to where we lived, and I had a pretty good collection of them. Like so many children, I came to be fascinated with something. At age 7, people would say, "Well, Bobby, what are you going to do when you grow up?" And I would say, "I'm going to become a paleontologist." And I did. I walked into that first class. It was in the geology hall at Rutgers University. It was the main geology lecture hall. The walls were all lined with geological images and pictures. There was a partial skeleton of a fossil animal on one side, and Dr. Wolf walked in the door and took his place. What a name for a geology professor, Dr. Wolf. And he was back from a summer of field work. His skin was bronze from having been out in the summer all year long. And I looked around at the things hanging on the wall, and I looked at Dr. Wolf. And the theme music to 2001, A Space Odyssey, began playing in the background. Bum, 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 bum. This has happened to you, hasn't it? Bum, bum. No, it hasn't. It will. It will. You'll have your day. Boom, 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 boom. Well, 60 years ago, I walked into that classroom 60 years ago next month. And I've been a geologist, I think, for all of those 60 years. I got my degree 51 years ago. I began teaching at a college and practicing my paleontology, doing considerable professional research, publishing in peer-reviewed journals. You've heard of them, but you've ever seen one? But I've seen them, the ones I've been published in. I've been retired for 7 years now, and this is what I do. This is what I choose to do. This is how I like to spend my time. Edifying you. Bringing geology into your life. And then I do the same thing so often. I think Tanya's seen this. I stand somewhere, and as I do so often, I wave my arm in a full 360-degree circle and say this is a dot on the surface of the planet. But to a geologist, this dot is actually 3 different worlds. The first world is the one that everybody sees. It's the world that's all around us. You live in upstate New York. Most of you live in upstate New York. And you know how pretty it is. You live in the Catskills. Can you imagine how jealous people must be that you live in such a place? It's a beautiful place to be. The first world is the world that everybody experiences every day. It's pretty, it's ugly, it's urban, it's rural, it's wilderness, it's the planet Earth. But it's only one of the 3 worlds that a geologist finds himself always. The second world is right through there. See what I'm pointing at? That's bedrock. It's bedrock. Wherever you go, somewhere beneath your feet, you get to bedrock. And if you're patient enough and look around enough, the bedrock will get to you. It'll be right at the surface. It's the job of a geologist to walk up to that bedrock and to examine it, to study it, and to make interpretations, to discover the world, that second world, as it existed when that bedrock formed. We're going to do that in a few minutes. It's what I've been doing for these past 60 years. Never walking past an outcrop, always looking into the outcrop, always trying to figure out, I wonder what it was like when this bedrock was forming. If I can figure that out, I'll have visited that second world, the world recorded in the bedrock. And there's so many of them. In every place I travel, every place any other geologist travels, there's that bedrock world. The third world is in the landscape. You're standing, this park has a name. What's the name?
Parish Field.
Parish Field. All right, it's a field. It's grass, people doing things, people picnic here, children play here. It's a park, it's a field. I wonder if any of you have ever paused for a minute and said, I wonder how this field got here. Or turned around and said, I wonder how that cliff got there. You know what? 300 years ago, if you asked even a highfalutin scientist, they would have just said, well, these things have just always been here. It's always been as it is today. The world formed, and the field was here, and the cliff was here, and the world hasn't changed. But I'd like to tell you a story about this field and that cliff, because I think I understand how the field got to be here and how the cliff got to be here. Isn't that a curious question? It's a kind of question that only a scientist would think to ask, and especially a geoscientist, a geologist, me. We're blessed, or maybe cursed, with a constant curiosity, asking questions such as this, which don't even occur to the vast majority of people. And there's absolutely no reason why you should have asked either of those questions. You've all been here, some of you maybe 50, 60, I'm a little older. Some of you are just children. And you know, all you really need to do to get through life is to manage your way from one place to another. You don't have to pause and ask, how did it get to be the way it is? But we do ask. I've been studying the Phoenicia area for 20 years or so, and when I knew I was going to do this, I made this map, put this map together. We are right here, I believe, and I found there's a unit of sediment which extends to the north. It fills the Stony Clove Valley with a mix, mostly sand, mixed with some gravel and cobbles, and here and there a boulder or two. And being that I have spent the last 60 years studying this sort of thing, I recognize that this was a glacial deposit, an ice age deposit. Well, if you take Stony Clove Creek and go to the north, you'll get to Stony Clove. And I'll bet almost all of you have been through Stony Clove. It's a big notch in the mountain. And you've maybe traveled through it 20 times, even 100 times. And you never said, "Huh, I wonder how this clove got to be here. I wonder how this notch came to be." Well, if I stand here and I look in that direction, in my mind's eye, I can see through the landscape and I can see Stony Clove. Very deep, very narrow gap in the mountain. But you know what? I transport myself 12,000 years into the past, and rising above Stony Clove is the profile of the glacier that fills all of Schoharie Creek. I can see, you can see it, turn in that direction. You can see Stony Clove for yourself, and filling it and rising above it is the blue, white, gray profile of ice. It's at the end of the ice age. The climate is warming. This is good climate warming, not the bad climate warming. This is the good climate warming, which is going to make the earth suitable for you and I to live in it. And that ice is melting. And enormous, vast volumes of water are pouring through Stony Clove, coming down Stony Clove Creek and reaching Phoenicia. We have discovered two things: how Stony Clove came into existence and how Stony Clove Valley came into existence. For a period of time, raging, foaming, pounding, thundering volumes, torrents of water were cascading through Phoenicia. If we were standing here at that time, we would be swept quickly to our deaths, dying, drowning in frigid ice water. There's a thought. We better get out of this place. It might happen again, you know. These things do repeat themselves. What an experience. You have your mind's eye, your human imagination. You are standing where I am telling you it was like 12,000 years ago. Raging, foaming, pounding, thundering, torrents of gray, white water, rushing, noisy as can be. It'll just burn out your ears if you're here long enough. And it eroded that cliff. All of the bedrock goes here, filling the valley, has been eroded away in the space of a couple of centuries. Yeah, this really happened. Well, when that raging, foaming, pounding, thundering ice age passed, and it eventually did, when the glacier melted from Schoharie Creek Valley and the flow subsided, this field was left behind as a mass of sand and gravel and cobbles. And it's been here ever since. The modern day Stony Clove Creek has eroded into that, but this has been here as it was all of that time. Think for a minute. To a geologist, this is the way it always is. Wherever you go, whatever you see, you're always conjuring up images of the past. You're seeing the world always as it was. You're seeing it as it is, the first world. You're seeing it as it was, the third world, the world of the landscape. And you're always living that life, or those lives. It's exciting to be a geologist. It's science. But it's not the science that, we're not in a laboratory. I'm not wearing a white lab coat. I don't have beakers going, bloop, bloop, bloop. Behind me, there's nothing going bzz, bzz, bzz. I'm a geologist, and this is geology. It's a very different world, a very different life. And you can read it every Friday in the Mountain Eagle. But we haven't visited the second world yet. Let's do that. Those are rocks. You're supposed to giggle. How many times in your life have you walked past massive outcroppings of rock? How many times have you driven down highways and left and right were massive outcroppings of rock? And how many times did you pause and think, huh, I wonder how those rocks got there. I wonder how they formed. And if you've never had that thought, there's nothing wrong with that. Absolutely no reason why you should have had that thought. But if you have had that thought, you're thinking like a geologist. But look at all these rocks. This looks like 10, 12, 15 feet of stratified rock. Down there at the very bottom is a horizon of sandstone. Frequently they call it bluestone here in the Catskills. It's the typical Catskill sandstone. There's a first stratum, a second, I see a third, a fourth, a fifth, a sixth. I'm not going to count them all. There must be a couple hundred of them. Pick out one of the thick beds. There's one over there. That's a moment in time when there was a powerful current of water. Flowing across the bottom of that water, this current transported a lot of sand. Had you been able to go down to the bottom of that body of water, and at that moment in time, you'd feel a powerful current, and if you keep your eyes open, you would see the water was dirty with sand and some silt and some clay. It was a traveling, moving mass of dirty water, and a big one. When that current slowed down, all of the sand it was transporting settled to the bottom in the space of a couple hours maybe, and I'm looking at a bed which must be 5 or 6 inches thick. A single depositional event. Well, likewise, these thinner strata in the stratified rock, each and every one of them represents a depositional moment. The current rose to a fairly fast speed. It picked up and carried sediment. Then when the event slowed down, that sediment settled out onto the bottom of this body of water. But when I say body of water, I'm being pretty vague. Excuse me, Senior Full Professor Dr. Titus, sir. Could you be a little more explicit about what kind of body of water is it? And I say, well, maybe it was an ocean. Maybe it was a pond. Maybe it was a lake. Maybe it was a river. Maybe we should call it a creek. But it was a body of water, and we're going to have to learn. We're going to have to study the evidence to decide exactly which of those is the case. And I'm going to go up and try to point to the evidence. Whoops. Right here, at a bad angle, I'm pointing to strata, which are not flat, they're inclined. Flat, 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 but inclined. You may be at an angle where you don't see that, but it is the case. The strata are layered or piled up one after another. Each represents a moment of deposition, a moment of speedy current slowing down and depositing the sand, but at an incline. Well, do you find that at the bottom of the ocean? No, you don't. Do you find that at the bottom of a lake or a pond? No, you don't. Do you find that in a marsh? Never, nothing like that. You do find it in a river. Yeah, when a river experiences a flood event, the currents pick up, the currents speed up, the currents sweep up all sorts of sediment and transport that sediment. And then when the current begins to slow down, the slowing current starts depositing that sediment, frequently in something that you might call a dune structure. In deserts, wind blows sand around into dunes. In rivers, the currents flow, carry sediment around, and deposit, in both situations, dune deposits. The front of the dune is always composed of inclined strata. So there it is. That's not the only evidence, but it's convincing evidence that this is a river deposit. A river deposit. Holy moly. Was this a Esopus Creek? No. When we find fossils in this unit, they are of ancient plants. Plants that lived during a time period called the Devonian. Plants that lived about 375, 380 million years ago. We have traveled all that length of time into the past, and we're finding that there was a river here at that time. River, the Parish River, let's call it. I get to call the names. I discovered the river, so I get to name it. The Parish Field River. Well, nothing could be more typical of the Catskills than the sandstones behind me. Throughout the Catskills, this is what we see everywhere. Climb to the top of Slide Mountain and you will pass these sandstones all the way to the top. Follow the Esopus River downstream, to say Middleburg, and you'll continue to find these sand deposits. There's river deposit after river deposit after river deposit everywhere in the Catskills. Why should there have been so many rivers here 380 million years ago? Well, that's where we have to jump in a car and go to the Berkshires. When you're traveling down the Mass Pike, 5 miles or so into Massachusetts, look to the left, look to the right, see the towering slopes of bedrock on either side of you. And if you know what you're doing, which only takes about 10 years to learn, you get out, you walk up to the rocks, and you recognize that these are the roots of mountain ranges. They're rocks that you would see if you could stand on top of Mount Everest and then descend into the earth about 5 miles. You would get to the roots of Mount Everest and you would find rocks similar to what you see on the Massachusetts Turnpike. The Berkshires are all that's left of a towering mountain range. If you know your way around, you may know that the Berkshires rise to about 1,200 feet. They are roots to mountains that some geologists think rose 30,000 feet above sea level. They were rivals of the Himalayas. Europe was colliding with North America. The crunch in between elevated rock into mountains which could have been 30,000 feet tall. Where India has been colliding with Asia, that collision has recently, over the past 50 million years, lifted the Himalayas to about 30,000 feet. We call these the Acadian Mountains. Today they're the Berkshires. I want you to think about that the next time you get onto the Mass Pike and you're heading towards Boston. Look at the outcrop on either side of you and think about it for a second. You are looking at what Sir Edmund Hillary would have seen if, instead of wasting all his time on top of Mount Everest, he had descended 30,000 feet beneath his boots and looked at the rocks that are down there. You can see those rocks. Hillary couldn't. The next time you're on the Mass Pike, maybe you stop at McDonald's, get out of your car, look 5 miles into the sky. Turn your 360 degrees, wave your hands. You're passing your hands through bedrock at the base of a mountain range. It rearranges your sense of reality to, if you play around with 300 or 400 million years, our world suddenly becomes that second world, the world that is preserved in bedrock. And we geologists, every day, every hour of every day, and everywhere we go, think these thoughts, ponder these images, see these, travel into the past, and see these ancient landscapes. Well, I want this trip to transform you. I'd like you to be a different person from now on. I'm only asking you to notice the landscape around you, the bedrock around you. You need to get 6 or 7 years of schooling to speak knowledgeably about each and every one of these outcrops. But at least I would like it if you were aware of what a person could learn if they did know, much of which you can learn by getting the Mountain Eagle every Friday.
I have a question. So the Catskills are not equal to the Berkshires? They were formed differently? They're not old mountains that eroded down?
The Taconic Mountains are the ones that you see when you look east. The Taconic Mountains are about 450 million years old. They formed when an early collision between Europe and North America occurred. And those mountains rose to, everybody agrees, 15 or 20,000 feet. That Europe backed away from North America, and about 50 to 100 million years later, Europe advanced once again, collided with North America. The two continents approached each other. Suddenly there was a collision between continents. Now, I'm just old enough, I remember before geologists understood this stuff. When I was an undergraduate, nobody knew plate tectonics. It wasn't taught. Professor Wolf didn't teach it. He didn't know it. And he wasn't able to explain mountains. It was a teensy-weensy little omission in his course. He never said, well, now we'll learn how mountains formed, because he couldn't. He couldn't say that. I witnessed what a privilege this was as a scientist, to be there when a major scientific revolution occurred, to be watching as it unfolded, and to have seen the transformation of my science as a result of this scientific revolution. There's no other way of putting it. A major upsetting of the whole field of geology and enlightenment. We understood so much more of the world than we did before plate tectonics. Now, the other thing I want you to do for the rest of your life living here in the Catskills, I bet a lot of you like to go hiking. I always want you to look at the bedrock. Appreciate the strata. Understand the strata and what they represent. You're looking at something called the Catskill Delta. At the base of the Acadian Mountains, sediment accumulated. First there was mountains and then an ocean adjacent to those mountains. And then the mountains weathered and eroded. Mountain streams carried sediment down the slopes, the west-facing slopes of the Acadian Mountains, washed that sediment out into the Catskill Sea, filled up the Catskill Sea, and began creating the Catskill Delta. When you get a chance, look at Bangladesh on your globe. Bangladesh is a delta, the Ganges River Delta, at the base of the Himalaya Mountains. When you look at the Himalaya Mountains and then Bangladesh beneath it, you're looking at a petrified version of the Acadian Mountains and the Catskill Delta. What I'm telling you, and I hope you'll always remember again, is that this thing that we call the Catskill Mountains is a petrified delta of the size of the nation of Bangladesh. If you took Bangladesh and you petrified it and lifted it a couple thousand feet and then let the rivers erode valleys into it, you would have something which was an exact duplicate of our Catskill Mountains. If you could take the Catskills and transport them 285 million years into the past, the bedrock would all soften, the bedrock would take the form of a great delta, forests, jungles would be growing on that delta, and you would have restored it to what it was like then. I'm telling you that the nation of Bangladesh and what we call the Catskills are identical twins, separated only by a couple 100 million years in the history that transpires during that length of time. Get an old National Geographic out and with an article about Bangladesh and look at it and look at every picture and appreciate that that picture could have been taken right here in Phoenicia 280 million years ago. My science is incredible. Every day of my life is like this, it's been that way for 60 years. I've made countless discoveries. My wife and I have written 1,300 newspaper and magazine articles, along with 5 books about this stuff. And all are available on Amazon.
I've meant to ask you this every time I've seen you, but why is there something about the Catskills that's like nowhere else in the United States that really stands out, and why did you choose to make your life's work here? I mean, I love it here. I'm just curious.
I'm going to answer you that question, and that is the art that it inspired. 200 years ago, the Catskill Mountain House Hotel opened, and among the people who came to it was Thomas Cole. He couldn't afford to stay at the hotel, but he could explore the 3,000 acres of land that it owned. And he saw Catskill Cove, he saw the view from the Catskill front, and he wandered the trails, and he saw the scenery that was in the Catskills, which truly and honestly at that time could be called wilderness. And it inspired him. He wanted to become a painter. He had been a portrait painter. He was a very young man, but he looked at this And he basically, there must have been a day when he thought, this needs to be painted. There's no other place on the planet Earth that did something as dramatic as that. I want you to look at the Hudson River School of Art. Go to your library and ask them if they can provide you with a book. I want you to look at the pictures. When you get a chance, I'd like you to go to art museums and see the paintings that these great painters produced. And I want you to understand that our scenery is what inspired a school of art, a whole school of art, the oldest known school of art here in the United States. It's part of our national history. It's an important part of our nation's history. It's the topic of our most recent book, The Hudson Valley Schools of Art and Their Ice Age Origins, available on Amazon or from the back seat of my car.
We did a walk too up to Catskill Clove, and he spoke about it, and I have a YouTube if you want to look at it.
Yeah.
For
yeah.
Catskill
About
Mountains.
the book at Mountaintop.
Yeah.
So I have the yeah, that's awesome. Cool.
Right.
Where did the delta drain into?
It drained into what we call the Catskill Sea. If you had been here at the right moment, everything to the east would be land, mountains would be rising above that horizon, everything to the west would be ocean. As the sediments poured down those mountain slopes,
So,
they swept westward
New
and
York
filled
City
in.
didn't exist as it did exist with the ocean was higher up enough into the Hudson
No,
Valley?
the ocean was down where ocean should be, about 2,000 feet beneath our feet. The crust here has lifted that much. 830 feet. Crust has lifted at least 830 feet. This river was almost at sea level, just barely above sea level when it flowed. Glacier bulldozed its way across it. It was the meltwater streams when the glacier melted that carved the depths of the great valleys of the Catskills. Yeah.
Right,
As
'cause
for-
there's Dutcher's Notch, there's all those notches up there. There's a couple.
Those are the glaciers filled into Schoharie Creek Valley right to the brim. And then when they started melting, they carved Dutcher's Notch, Jimmy Dolan Notch,
Yep.
and half a dozen other notches.
Yeah.
Each and every one of them, when you get to them, I want you to look to the north. The space in front of you is filled with ice, but it's melting. And you're standing at the bottom of a notch, and you're feeling the ice water passing through it like 40 miles an hour
Okay.
at that moment in time, and carving that notch. Diamond Notch, a wonderful meltwater notch.
So the Catskill Mountains were not actually lifted up like other mountains through plate tectonics. They were carved out.
They lifted and were carved. Okay, that's a difficult thing to explain, but I'm going to try. You have a great mountain range right here, and vast quantities of sediment are coming down its slopes, and the sediment is piling up until it's 3 miles thick, and it presses into the crust, deeper and deeper and deeper, but the surface is always just about at sea level. So, a mass of sediment forms. It is populated, it's the top of a delta. It's 5 feet above sea level. It's got a forest on it. But then sediment piles higher and higher and higher on it. It's pressed down into the earth. Maybe 2,000 feet. Then the mountain building is over. The sediment stops washing out of the mountains. The weight is no longer pressing down, and the crust rebounds. Sediment that had been deposited at sea level was pressed into the crust and is now rising back to the surface. If you can follow that, you're a damn good geology student. If you can't follow that, you're to be forgiven. But the sediment comes down, is deposited on top of a delta at sea level, just about sea level. It piles higher and higher and higher. Each stratum is driven into the earth until the mountain building ends. And the crust begins to rise once again, bringing sediment that formed at sea level back not only to sea level, but to well above sea level.
Well, at least 4,000 feet, right?
Yeah.
Because it's slide.
Yeah.
Yeah.
And then there's more erosion that causes the valleys and
then subsequent river erosion, Schoharie Creek, Esopus Creek, erode valleys into that strata. Late at night in geology bars, they debate how tall these mountains were. Were the Acadians 30,000 feet? Maybe. A lot of people think no, they were only 15,000 feet. At about 3 in the morning, in a geology bar, the answer appears, but nobody can remember it the next day.
But this is very unique to the Catskills. There's not many other mountain ranges where this type of activity formed
There are many other ways of forming mountain ranges, most of which have to do with colliding continents.
Right.
And what you're looking at has only indirect relationship to a colliding mountain. If you insist upon plate collision, then you would argue that these are not mountains, but they're mountains.
Didn't I read in one of your books about an ice dam?
Yes, yes. When the glaciers retreated to the northern tip of the Adirondacks, there was a moment in time when they blocked something called Glacial Lake Iroquois, which was 5 or 6 times bigger than all of the Great Lakes combined. It was one vast, not Great Lakes, but one vast Great Lake, Lake Iroquois. When the glacier got just north of the Adirondacks, a little trickle of water passed between the Adirondacks and the ice, and it began the draining of Glacial Lake Iroquois. In the space of a few days or weeks, the trickle turned into something that the word torrent doesn't begin to describe. An enormous lake drained down to Lake Champlain vicinity, to the Hudson Valley vicinity, and into the Atlantic Ocean. To stand at the Catskill Mountain House site and to look into the Hudson Valley on that day and to watch an enormous flow of water, nothing on the earth exists like that today, would have been incredible. Would have been an incredible experience. When you stand on the Mountain House ledge, look down, fill the lower Hudson Valley with raging, foaming, pounding, thundering torrents of meltwater, and you will experience one of the great moments of the past.
Is that what the Hudson River is now? Is that,
Yeah.
Okay.
Yeah, and rising maybe 50 or 100 feet above the river, maybe more.
Okay.
Yeah, yeah. You look down and see that, and you go, this Titus is onto something. Yeah, yeah.
Someone told me that a meteorite hit near Panther Mountain. Yeah, and I've been meaning to ask you that too. What is that about? Is that local lore? Is that true?
That's about late at night in geology bars.
Yeah, that's what.
The Panther Mountain is circular.
Yeah.
It's very unusual. It's extraordinary, but it's a beautiful circle. On account of that, a New York State Museum geologist named Ingvar Isaacson, my wife and I knew him, he said, it can't be, it couldn't possibly be, but maybe this was an asteroid impact. And if it happened when the Catskill Delta existed. It's as if a 6 mile across a quarter mile across asteroid hit Bangladesh. Slammed into Bangladesh, creating a big circular crater, which was subsequently buried. Now, there are a number of geologists who think that this has been discredited. But popular science writers love the idea. So my wife and I are not ready to give up on this idea. But I think a majority of geologists think that no, it didn't actually happen. Yes, Panther Mountain is circular, but something else did that.
Well, do you think it happened? The question, because you would know more than the other people, because you live and work here, right?
I
I'm
have.
serious. You've lived and worked here a very long time.
My wife and I have played it both ways. Early on, we wrote of it as if it really happened. And we gazed to the southeast, and every night for a month, and in the darkness we see a pinpoint of light, And day after day after day, the pinpoint of light gets brighter and brighter. And suddenly, we get up in the darkness of a new night, new coming night. It's glowing. It's red. And then we swear we can see sparks flying off of it. And we know, oh, fiddlesticks. It looks like an asteroid is approaching the Earth. Oh, double fiddlesticks. I hope it doesn't actually hit the Earth. We watch and we watch and we watch. And the brilliance of the glow gets brighter and brighter and brighter. And then it disappears over the horizon. And we go, oh, fiddlesticks. It's hitting the Earth. A great, enormous flash. Blinding white flash. Big circular or half hemisphere of light rises above that surface. Then we see a plume of blackness. It has a mushroom-shaped top to it, rising and rising and rising above the horizon. 10 seconds, 20 seconds, 30 seconds passed, and all of a sudden, the earth shakes beneath our feet. We're on the Catskill Delta. There's a forest of primitive trees with poorly developed roots. They all come crashing down. 10 seconds, 20 seconds, and a blast of air sweeps across the surface. It is the impact blast. It is a shock wave passing through the atmosphere of the planet Earth, radiating out from the impact, which is in northeastern Pennsylvania. We watch and we watch, and that nuclear winter cloud is rising higher and higher and spreading out above us. Right above us, the stars are still shining, but we look and we see the blackness getting closer and closer and closer to us. Soon, something worse happens. Fiery masses of burning foliage come crashing out of the sky, landing to the ground all around us. There is a forest out in that direction, and it is on fire. It is a wildfire. Doesn't begin to describe what is going on right here, and we're standing and watching it. Soon it gets even worse. Great clumps of molten rock come crashing out of the atmosphere above us. They've been thrown up by the impact 30 miles into the sky. They were pulled by the Earth's gravity back to Earth towards us. On their way down, friction with the air generates fire. These boulders, these masses of rock, catch flame and come crashing down all around us. We're the mind's eye, the human imagination. We cannot be harmed by this. Then we smell the odor of sulfur, and we know that vast quantities of sulfur have been blasted out of the ground and are permeating the atmosphere all around us. It gets worse as enormous volumes of sediment start raining out of the sky and piling up on the ground all around us. Some of it is ash, some of it is just broken rock debris. We know that we have experienced something that very few people ever get to experience: the impact of an asteroid with the planet Earth. That's better than chemistry, isn't it?
Yeah, I love it.
We've used up our time pretty much.
All right. Well, I think everyone's happy.
Thank you.
You rock.